Welcome everyone. Let's see. Okay, good. We're recording. All right. So today is the 17th of March, 2021, and we will be talking today. Let's see. We're talking about how to define the research problem. Let's see. Okay, and then let me see. Actually, a couple of things. One other thing I want to talk to you guys about is I posted 2 assignments. One of them is a short paper that I want you to write. The other is a longer paper that I want you to write and present. I'm still working out the details on how to be able to fit all this in one semester. So some of the details, some of the requirements might change, but basically what I want to do is I want to cover 2 aspects of the course. One is the scientific research methods part, and one is the more kind of ethical part as well. So one of the papers is going to be basically kind of like a literature review, a critical survey of a topic, of a research topic. So for those of you who have already begun work, which many of you have, on some type of thesis, or if you've already finished a thesis for your master's program and you're a doctoral student now, basically this is going to be kind of like your related work section, maybe an expanded related work section. So that's one thing that I would like you to do. I would like you to also include as part of that, though, is go ahead and focus on one is what were the methods of the research, like what we're talking about here is how was the scientific method, how was the for the citations that you'll use, what methodology did they use to perform their research, like what types of experiments and stuff like that. The other part of that would also be, I'd like you to also kind of make some commentary on ethical aspects, the ethical questions that come up as part of the research in the area that you're focusing on. We've talked about it before a little bit. I mentioned, like, for example, in autonomous vehicles, in the artificial intelligence arena, the self-driving cars, that we've talked about some of the ethical implications that are having to be discussed in terms of what is how to decide whether to turn left and avoid maybe an animal or a person, or possibly go straight and avoid doing something else on the other side. There's all kinds of ethical implications of how to program these autonomous vehicles. And so for the related topic that you'll be writing about is what are some of the ethical implications. The other assignment is I want you to make an argument. I'm going to there's, I believe, 20 students registered for this course. So what I'm going to do is I'm going to come up with 10 debatable topics. And what I'm going to do is I'm going to assign to each of you a topic and which side of it that you're supposed to take to make an argument for. Okay, and I'm not saying you have to agree with the argument. I'm not saying that what you have to do is come to a place of believing that side. What I am saying is I want you to research the arguments in favor of the position that you have to come to. Okay, so again, you don't have to agree. I just want you to present the arguments in favor of a certain viewpoint. Okay, I think this is important for us, just for us, the human race in the world today, to be able to see multiple sides of an argument. Okay, again, you don't have to agree with it, but you will. I do want you to present the points in favor of a particular way of viewing things. Okay, again, this is possibly a pie in the sky. That's an old phrase. I can't think of a Turkish equivalent, but a pipe dream. Pipe dream is the other phrase of mine. But I would like you to write both of these, and basically what it is that if you look at the syllabus, there is in-class discussions is 10%. There is an assignments portion that's 30%. That'll be the small paper. The small paper will be the 30%, and then the larger paper and presentation will be that 60%. And what I'll do is I'll store that as your final exam grade at the end of the semester. Okay. If there's any questions related to that, we can talk about that. I'm going to let you guys digest some of that first, but for now, let's go ahead and get into the discussion based on the slides. I guess I got to share my screen before I can do that. Okay. All right. So the topic for today's discussion is we're going to be discussing how to define a research problem. Like, you know, we have ideas of what we want to study, of what we want to research, what we might want to perform an experiment to figure out. But one of the things that we really need to do is we need to be able to come up with a solid, clear definition of what the problem is. Oftentimes, no, I wouldn't say oftentimes. I would say most all the time. I don't like using the word always. Many of you who've encountered me before know that I don't like using the word always. I don't like using the word never. But the first step is going to be defining what is the problem. Writing the problem statement. In fact, for those of you who've had me as an advisor before, that's the very first thing that I want you to do is write a problem statement. What is it? What is the problem that you're trying to solve? Okay. So what is a problem? So, I got, this is according to the text that we're using for this class, and basically some difficulty that experiences, because if there's not a difficulty or if there's not a problem in some way that needs a solution, then we don't really have a problem, right? If there's already a solution that works best, then we don't really have anything that we need to solve, right? Okay, and some points that need to be considered is, is there an entity, or this could be an organization, this could be a person, this could be, it could be a country. It could be all kinds of different possibilities for what the entity is. But, can we attribute the problem to someone, all right, or to some group of people? There must be at least 2 courses of action that can be taken, because if there's only one course of action to solve the problem, then we already have the solution. There's no reason to research any alternative solutions, right? For the courses of action, there must be at least 2 possible outcomes, and one should be preferable to the other. In other words, one is more desired. So, if 2 possible outcomes and they're both equally okay, right, then we don't really have a problem, right? We can just take the 2, either course, it doesn't matter. We can flip a coin for how to get there. Right, and then we should have a unique probability of achieving whatever the objective. So if the course of action, if we've decided what our outcome is preferable, and one course of action has a certain probability of achieving the objective, and if the other course of action has the same probability of achieving the objective, then we really, again, we could just flip a coin. There is no problem there, right? So we must have an ability. Now, this is not to say that we know these things at the beginning. This is not to say that at the beginning of our research that these things are all known. It's just that the problem must have these characteristics in order to be considered a research problem that we may want to study. Okay. As for selecting a research problem, so especially for those of you who have not already kind of put yourself into a particular research area, if you're still considering what research area, what problem should I study, should I write a thesis on, these are just some general guidelines that are presented here. One is you don't want to necessarily have an overdone topic. Maybe during the break I'll find there's a comic that kind of talks about this, that as you begin looking for articles, as you begin looking for existing research on a topic, initially you'll start out and you won't you won't have anything because you haven't searched anything. You won't have any sources related to your topic. Okay, that's expected. As you start searching for research related to the problem you're wanting to study, you're going to start finding articles. There's this graph that is in this comic, and I'm going to find it during the break now. That kind of talks about eventually you get to this peak where you have enough research, you have enough bad is, no, Seth, the problem with bad is that's more of a subjective term. Yeah, I would say that's more of a subjective term. So I would say it's not always the case that it's bad. Sometimes it could just be that we have a lack of knowledge in a certain area. Not all research is necessarily intended to solve, problems like world hunger or I don't know. Not all research problems are related to trying to solve a pandemic, right? There is research in those areas, of course, and those I would consider world hunger and people getting ill and dying from a virus. I would consider those to be bad things, right? So definitely that problem would be something bad that we're trying to overcome. I would say other problems such as we don't have self-driving cars is the one that I keep coming back to. It's not terrible. It's not a bad thing we don't have self-driving cars, but it's just that maybe things could be easier. Things could be, truth is, like anytime I've gone on a road trip, there's a part of me that's a little bit jealous of my kids in the car who get to watch their movies or read their books while I'm driving, right? And there's a part of me that's like, I would like to be able to do that. So it's not bad that we don't have self-driving cars, but it is something lacking, maybe something that could be that does not currently exist. Maybe we can put it that way.
All right, so
what's that?
So there was a little confusion there. At first you said problem, and I thought topic. And then you used the term difficulty, and then I thought, a problem with the research itself, like you can't get the resources for the experiment or something. So there's a little bit of confusion. But you mean like the topic. Right?
Yeah, so when we're talking about defining the problem, we're meaning more the topic of what you're going to research, whether it be a search for existing material to compile into a critical review or a summary of the state of the art type thing. Some papers don't have any kind of experiment or anything. They'll just have kind of a summary of the state of the art that's out there. And so the problem may be there's no existing document that kind of compiles all the existing research together in one neat package. That might be what we mean by problem. Yeah, so good question. So as far as the overdone, where I was going with that was you don't want something that's been studied and done and so much that the problem, the topic is already kind of solved, if you will. Like I said, I'll show you a comic with a graph on that. Another guideline: controversial topics should not be lightly considered. In other words, controversial topics can be interesting, but it doesn't necessarily mean that we should always be the ones to study them, because it can, especially if we don't do a very good thorough job of it, it can cause problems, bad problems, in this case, bad problems if things are not done well. Narrow or vague problems should be avoided. We'll get into a couple of examples at the end, some ambiguity in the examples at the end. Should be something you can be relatively easily engaged with. So if you have the resources available to you, whether it be through library research or through IEEE or other document journal repositories, then you should be able. Then that could be a good topic for you. Or if it requires some type of experimentation and you have access to the materials or can get access to the materials pretty easily. Like I would say for me personally, if for some reason I'm not a physicist, but or in any of those fields, but if I needed to get access to CERN, for example, to a collider, I don't really have access to that right now. So if I'm not really going to select a topic for research that's something that would require such a thing as that. Okay, so again, that's partially under the other factors being considered, the availability of resources. If we don't have access to them, then we probably need to consider other topics. Okay, yeah. So as far as that final point, the preliminary study, do a preliminary kind of light research of what's out there already to see what ideas have already been engaged in. If you have a potential idea for a solution to an existing problem, do some preliminary research to see if the idea that you're wanting to attempt is already been tried, or if it's already been tried, found successful, or found lacking. Also consider that in a lot of papers that you'll run across, future work and related work could be a really good section to get some ideas for things that have not been tried or have been considered. Okay. Okay. One thing is we need to make sure we state the problem well. We need to make sure that we don't have a lot of ambiguity. You want to make sure you answer important questions. What data will be necessary? What are some of the characteristics and the relationships between different variables? What techniques? What type of, again, this also falls under the whole area of resources. What resources will be necessary? And so how will you go about answering the question of whatever the problem is? So make sure you kind of really go through and analyze what it is you're trying to solve, what it is you're trying to learn. Again, the problem might not, like Seth and I just discussed, might not be specifically some type of problem that has a solution in the form of, people are dying from a virus, we need to have a vaccine. That may not be always the type of problem that we're studying. It could be that we want to learn more about this topic, right? That could be the problem in and of itself. All right. So some of the things that you'll want to engage in, so the problem statement, you'll want to come up with an initial problem statement, again, as much as possible, avoiding ambiguity, and really kind of get a good solid idea of what specifically the question that you're trying to answer. Understand what the nature of the problem is, what field of research is this in, what some of the things that you'll need to be able to answer the question that you're asking. Perform an initial literature review to just kind of learn what's out there, making sure that you get current documents as much as possible. Now, that's not to say that stuff that's decades old is unimportant, but oftentimes what we want to do is we want to make sure that nothing in recent years has already answered the question or made the question uninteresting or made the question unnecessary to answer. So You want to have a good mix of foundational documents that are older and kind of foundational to the field, especially if it's a field that's been around a while. You know, like, I mean, if you were in something like a medical field or a biological field that maybe has been around a while, you may want to have some documents from that are more foundational, and then you would also want to have newer. You would want to have newer documents, the newer articles, so that you can show that you've kept up with the state of the art. Okay. You want to go ahead and seek out interested parties and experts in the field to get kind of their input on things. So if there's a professor here at the university that's knowledgeable in the field that you want to study, go and talk with them. Go and talk with that person to get an idea of what their thoughts are. If there's somebody that's not here at the university that's in that's somewhere else, reach out to them and see if they'll be interested in talking with you about what are some of the things that you're not thinking about that maybe they have. All right, and they would hopefully be interested in hearing from you as well, because maybe hearing the thoughts of a new person coming into this field. Okay. And then once you kind of add all that together, you'll want to go back to your original problem statement and edit it, kind of reassess. Okay, what are some of the what were the problems with the problem statement, right? And so what kinds of new what new information needs to be added to the original problem statement? Okay. Some of the good aspects of a problem statement. I should probably call this the problem statement. Should be the title of this slide, maybe. You want to have some clearly defined terms and clearly stated assumptions. If there's terms that are particular to your field, to kind of like the finer topic that you're covering, and it may not be known to a broader community, you want to make sure that you define those, make sure that those are understood. If you make assumptions, make sure you state those and make them clear what it is that you're assuming. You want to indicate, why. What is valuable about the topic that you're trying to study, right? It's if it's just kind of like, oh, I was just wondering this one day and I wanted to know what was going on with this, that's maybe not gonna get a lot of interested parties, right? But if you can give a good, solid what's the word? Support for why this even should be studied in the first place, that would be definitely very helpful. You want to include some current sources, like I said, and you want to make sure that you have a clearly defined scope. Like, you don't want to say, oh, I want to study why is the world crazy? I don't know. It's like, that's kind of, what does that mean, right? You want to keep the scope. You want to make sure you understand what are the boundaries of the research. Okay, so I have a couple of bad examples. That I would like us to consider and kind of help us understand why are these, what makes them bad? What are these not okay examples? These not okay research topics? Yeah. The second one is kind of, that one's for you, Seth. So what are the problems with these examples? Like, what makes them bad research topics? Like, why are bad problem statements?
Ambiguity.
Yeah, there's a ton of ambiguity in there, isn't it? Well, let's just take a look at one at a time. Okay, let's take a look at the first one. What's ambiguous there?
According to which criteria or which properties we can ask.
Yeah.
So, yeah.
Right. Yeah, they're too generic. Like, what does healthy mean? Like, what is it? What does healthy mean? Like, are we talking about physical health, mental health? Right. There's all kinds of meanings of healthy, right?
Yes. Yes.
Is there an assumption in the first one that we're making?
So, Professor, it's also important that researching these problems in which aspects, you know, it's there's some kind of ambiguity there, like why Americans less healthy than Turks. It says in which aspects, for example, in which ways, you know, we need to declare that to solve the problem, because understanding the problem, as you mentioned, as important as define the problem, because if we don't understand the problem, we cannot solve the problem, you know. And yeah,
Absolutely. All right. So what would be a better thing that we said? Oh, wait, going back to a question I said, are we making an assumption and not stating it and not making it clear what assumption we're making in the first one or the second one? I mean, both we are really. Yeah, Seth is like, there's many assumptions. I mean, the very first one, we're making an assumption that Americans are less healthy than Turks. Like, but, you know, and so the question is, okay, so is that true? Are Americans less healthy than Turks, or are Turks, more healthy than Americans? Right. Right. And so what we might want to do is we might want to say, okay, well, I've noticed that maybe somebody might say, I see in terms of the population statistics that Americans on average struggle with obesity more than Turks. We might say that. I don't know that for a fact, by the way, so don't quote me on that. But that might be something we would say, okay, that's something that we can say, why is that, right? Why can we look for reasons that, assuming that's true, again, that's an assumption on my part, right? We might say, okay, why is it that on average, more Americans are more overweight or struggle with obesity more than on average most Turks? Okay, and that might be something that we could study, because now you're saying, okay, now we're being more specific, because now instead of just saying healthy, whatever healthy means, we're saying, okay, we're going to talk about a specific aspect of health, which is weight, your body weight, or not even body weight, but what is it? BMI, body mass index. Right. And so if we have some documented support that Americans have on average higher BMI than Turks do, now we can ask that question: why is that the case? Why is that? Why is there a higher BMI for Americans than Turks? And now we're getting more specific, right? And something that's testable too, right? Something that we can look into and actually do more objective research to figure that stuff out. So what was the other one here? The computer programmers better employees than physicists. Well, I think computer programmers are better employees than physicists. Right, Seth? You agree? Yeah, I'm picking on Seth because his background is physics. But this is another one of the things that was like, it's Aisa. Yeah, so again, we don't know. We don't, and again, what is a better employee? Is it someone that shows up on time more? Maybe. Is it someone who has, I mean, how would you even compare efficiency in two different fields like that? If you had one employee, one person who's considered more efficient, how would you test that across two different fields? Right. Right. So how would you do that? I mean, how would you do that in terms of work efficiency? You would have to have some type of metric, right? There's all kinds of things we'd have to figure out. How do we test for those things? Right. So what I'd like to do, if possible, we have a few minutes left, about 15 minutes before the scheduled break time. If some of you who have already begun your thesis or written your thesis, especially for our doctoral students, who have already defended their master's thesis, what were your research problems? What were your problem statements? And maybe you could share that with the rest of us so that those students in the group who are just kind of starting out can kind of get an idea of how to structure their problem statements. And you guys in the chat, those are some good comments and good questions that you're thinking through. Okay, what does that mean better? What does that mean? Right, exactly. That's exactly how you need to be thinking. So who's let's see, who are my doctoral students? I know Seth is. Erdinch, you are. Who else do I have? Is Melee in here?
Yes, I am.
Okay. Yeah. So would one or a few of you be able to share with the group kind of what your problem statement was? And you don't have to go into really long detail, but just kind of how did you structure your problem statement to be well defined? Put you guys on the spot like that. No, I apologize for that. Yeah, like that. Yeah, I mean, you would include aspects of your problem statement in the abstract. There's no doubt. But it doesn't even have to be as long as the abstract. I'm really just kind of asking you to explain, what was the problem you were trying to solve with your research for your thesis. So maybe Seth, since you commented that, Asa, unless you're trying to join because you're ready. Go ahead.
I may talk about my project. How did I start working on it? On how did I start working on my thesis? So first of all, my thesis was related to cancer driver genes detection. So about creating or generating an algorithm that as an input, we have some patients data and some mutations data, and we come up with an algorithm that prioritize driver genes. Then, so these genes, whenever we have some, these genes are mutated, we can say that this cancer type will be reason. So, as a starting point, I was searching about the state-of-art algorithms that exist, which already created. So I found many algorithms from 2012 until 2019 and 2020. So I tried to create an algorithm that beats their accuracy, let's say. So basically, this is how I started that, and this is how I defined my problem: is that am I able to create an algorithm that prioritize more driver genes than the other algorithms, and also are we able to define some novel genes that are not yet discovered before? So this is how I started.
So, wow. Yeah, that sounds very interesting, man. Well be above my pay grade, as we would say. So, and what were you able to figure out? Like, what was your did you have a hypothesis? Did you have
So so many algorithms are using many data. So our hypothesis was about, are we able to use few data and discover and prioritize more driver genes than the other methods. So for other methods, they were using much, complex data, but for us, we tried to minimize the data, and in order to minimize the running time of the algorithm. Yeah, that's it.
Oh, so it improved efficiency then?
Yeah, improve the efficiency and also try to discover new driver genes compared to the other methods. So,
cool. Very cool. So, Mohammed, I'm reading yours about the predicting the user ratings to recommend personalized movies. So this be like for Netflix? Like you would use this for like a Netflix or other type of streaming services to give suggestions for movies to users?
Yeah, it was like recommending movies on Netflix.
So what was it that was a lot of times if there exists something already, because I know that like when I log onto Netflix or onto YouTube or anything like this, they often already give me suggestions. So what was it that you found lacking with the existing solutions for this?
Actually, there was a problem with actually we minimized the error rate with the previous one. So, for example, if we predict the rating for 1%, the error rate is around 0.7 mean square error. So we try to reduce it. So in that way, we can recommend better movies to the users.
Okay. Cool. So Seth, I didn't want to call you out first because I mean I'm more involved with yours, but maybe you can explain also what was the gap, what was lacking in what was already existing, and how is your proposed research going to improve on what exists?
How to describe? So when choosing a journal to submit a paper, there are many, many choices, thousands and thousands. Many of them are closely related journals, but they can differ in the nature of the articles published. And so to get the best fit based on relevance, I used artificial intelligence to magnify the differences between these journals to help make recommendations that are more relevant.
Okay. Also, one thing also was that a lot of the existing solutions, or at least the two that you compare to and you focus on, were So it's like a proprietary type thing, right? Where you had a particular journal that a particular journal publisher that would have a recommender system, but would only recommend their own journals, right?
Yes, that's an additional part of the problem. They are proprietary, also less based on relevance, based on older techniques, and less accurate as well.
Yeah, so a lot of places to try to improve on the existing solutions, right? Let's see.
Exactly.
Well, would anyone else like to briefly mention kind of what their proposed research problem statement might have looked like, so that the younger students, the newer students, could get an idea of how to structure theirs? Anyone?
In my case, I
Okay.
didn't really create the problem myself. I was added to an existing project, and that project had a problem. I tried to solve that problem using machine learning algorithms, especially deep learning. In that problems, doctors try to segment the eye into 3 regions, actually 4 regions: background, sclera, the white part of the eye, iris, the colorful part of the eye, and the pupil, that's the center of the eye. I segmented the eye images into those 3 parts in order to solve an existing problem. Therefore, I didn't come up with any new technique or method to solve this problem. I just apply existing methods to that problem.
So what was the problem with the eye, with the what was it that was trying to solve?
Researchers wanted to see whether we can detect epilepsy from the eye movements. So in order to effectively check the eye movements, I try to segment the images from the video using deep neural networks. Therefore, we could maybe mathematically formulate the eye movements. Then maybe we can see the relation between the epilepsy seizures and eye movements.
Right. Well, but this isn't a great example of a problem statement, is because what the researchers were trying to determine is, can we kind of, if I generalize a little bit, is can we detect a disease or an illness or something along those lines from eye movements or from a particular way that a patient's body part does something, right? So what your part in this was using the technology and using the deep learning to be able to analyze the eye movements to say, can we detect this disorder, right?
That's correct. With eye segmentation, I was also able to mathematically calculate how much for example, people grow, how much it shrink, how much the sclera went to left or right, whether the patient only was staring or during that blank phase, whether the patient's eyes are that any sort of movements. There are some sort of pre-information about these cases where we were already knowing. So, for example, there are some sort of epilepsy cases where the patients are only looking blank to a wall and without any movement. So they don't even know they are having a seizure, and the time between seizure is almost erased in their brains. So we wanted to see whether if we can detect any different kind of, eye movement before the epilepsy seizures to prevent it from happening, but it was really, how can I say, an early stage research. It needs to be explored more. We need more data. We had around 20 patients, and in medical area that number is not great, but we made a step forward with idea, so other researchers can take that idea and improve it further if they can see any relevancy between the problem and our method.
Yeah. Sounds like an interesting research for sure. Yeah, but again, yeah, that's a great problem. Is can epilepsy be and a seizure be detected through a person's eye movements? You know, that's the question: is can it be? And that's what the problem statement would be. Is the problem statement? We don't want to answer it. We don't want to answer it in the problem statement, right? But that was a great example. So, Ismail, I think you were about to speak earlier, right?
Yes, yes. In my thesis, I am planning to create a 3D model more accurate and precise. I am investigating existing solutions for that problem.
Mm-hmm.
I am trying to investigate it for now, but I don't have any problematic definition for that for now.
Okay, so you know what you know that you want to create a 3D model, but you're not necessarily sure what the problem that you're wanting to use that for is. So you have a kind of a technology.
Actually, there are lots of problems. For example, device problems. You need to scan it with some devices. So some devices uses lens, some of them uses laser. I am trying to investigate all of them for now.
Mm-hmm.
Each one will be useful and cheaper and create more precise and accurate 3D model. I'm trying to. It's like that.
So it sounds to me like what you're saying is your problem statement is which of the technologies will produce the cheapest, most accurate 3D model.
Yeah, most accurate and precise.
Mm-hmm. Okay, cool. Yeah, so there you go. That's a good problem statement where you have a something that's testable because you have, by saying okay, the cheapest and the most accurate is that you can measure that kind of thing, right?
Mm-hmm.
All right. All right. Well, if anyone else is just really wanting to talk about their problem statement, they can. Otherwise, it is right at the first break time. And I hope that a couple of those good examples there will help. But Berk, you're wanting to speak?
Well, yeah, I'm a master's student. I'm not a doctoral, but in my graduation thesis, I tried to answer the question of can we identify persons using their own gait. So we were trying to record the people walking, and so we were trying to understand how we can analyze and try to identify them. So, and this would allow us to use this in very public spaces, so we can maybe detect some anomalies and such stuff. This is my graduation thesis, basically.
So then your problem statement would be, can we identify an individual person's identity based on their gait, based, as you said, based on the way that they walk?
Yeah.
Wow.
Yeah. I mean, this is there's a lot of studies actually on this area, but we try to use different voting methods to decide which machine learning algorithm performed better, and we give more weight upon that machine learning algorithm so we can get better results.
Wow.
It was like that.
Cool. Did the participants know that they were being studied for this?
Yes, yes, of course.
Because I'm wondering if there was any just in my mind, I'm thinking, would I walk differently knowing that you're recording me walking?
Yeah, actually, we noticed that there was a little bit of difference between a test recording and like real-time recording without them knowing that we were recording. Of course, we asked for their permission, but like there was a little bit of difference, but it didn't really make that much of a big difference.
Cool. Interesting topics. A lot of different topics. Some health, some identity, some other things. Yeah. Some journal publications, movie review, movie recommendations. Yeah. Cool. So hopefully those of you who I can never say your name right. Isalkin. Hopefully what you guys have seen, heard in the other students sharing can give you some ideas of how to structure a clearly defined problem statement. So, all right. Well, let's go ahead and take a break. We'll be back at 2:33, 2:33, something like that, in about 10 minutes. And we are going to discuss, I posted an image of a portion of a document from the university related to a cheating policy that I would like us to discuss in the second hour. Okay? All right, so I'll see you guys in about 10 minutes.